Hey geometry team, and welcome to Unit 7, Day 3. We are going to be learning about the properties of trapezoids and kites today. In our last lesson, we focused on all the things that were parallelograms. Now we're going into these goofball trapezoids and kites. So to start off with your trapezoids, here's a lovely example over here on the side. We have several things to remember. First of all, they only have one set of parallel sides. Those are called your bases. So here on the top and here on the bottom are your parallel sides. And so this is the short base, this is the long base. They could be on the sides if I were to rotate this. So just be aware, it's not always going to be shown exactly like it is on this screen, but the two sides that are parallel, wherever they are, will be called your bases. The non-parallel sides are called your legs. That was very complicated. Try not to cry. And so in a trapezoid, the adjacent angles between the two bases are supplementary. So this red angle and this blue angle here, these two are going to be supplementary angles. The reason for this, if you recall from our parallel lines unit, is that if you have a parallel here and a parallel here, this is basically a transversal. And so these are same side interior angles. They have to be supplementary. I've marked them in different colors because we have no way of knowing how big they are. They are not necessarily congruent, but they should be supplementary. The same with these two. I've got parallel lines and a transversal cutting them across. And so these two angles right here have to be supplementary. Trapezoids always have these two guys and these two guys being supplementary. And so all together, they should add up to 360. Just a little bonus fact for you. And so that's really all we have on just ordinary trapezoids, is the fact that those angles should be supplementary. But then we get into the special guys, the isosceles trapezoid. This one has a lot of properties that get going on it. So remember, first of all, since it is a trapezoid, the bases are the two parallel sides. And so here they are right here. To make it be an isosceles trapezoid, that's where you're going to get that these two legs, so the green guys, these legs connecting the bases are congruent. The parallel sides will never be congruent. It's always going to be the legs that will be congruent in an isosceles trapezoid. That's what makes it isosceles. You can almost imagine it being an isosceles triangle where its head was chopped off, and then you're just left with the two congruent pieces here at the bottom. When you have an isosceles trapezoid, just like in an isosceles triangle, the base angles are congruent. So these are considered base angles, but if you flip it over, these are base angles as well. And they are also going to be congruent. So now there are two sets of base angles. So the set that's marked single here, they are congruent to each other. And then these base angles down here on this base are also congruent. So you've got two bases, and now you have two sets of congruent angles. The diagonals, these purple guys here, are also going to be congruent. If you think about that for a minute, you had the sides congruent, you had this base along the bottom here, and then you had this angle down below. So these two triangles on the bottom here would be congruent by side angle side. So the diagonals, the purple guys, are going to be congruent in an isosceles trapezoid. This only happens because the legs are congruent. So we've got congruent diagonals and congruent sets of base angles. The adjacent angles between the bases, just like in an ordinary trapezoid, these are still supplementary. So this guy on top and bottom here, and this guy on top and bottom here, those are still supplementary, but now they just happen to match the one across from them as well. Bonus though, since we had congruent legs, these opposite angles are also supplementary. So we had these adjacent ones were supplementary, but since top angle 1 and top angle 2 are congruent, I could use the transitive property, and now this bottom angle must be supplementary to this guy. So the bottom angles are supplementary to both of the top angles. Fun little bonus there. Thanks to just these two little side guys being congruent, being isosceles, suddenly you've got all sorts of supplementary things going on. And here it is marked to remind you that either of these two base angles is going to now be supplementary to either of these top base angles because it is isosceles. So to go back over it again, the base angles are congruent and the other base angles are congruent. The diagonals are congruent. The legs are congruent. And then any angle on bottom will be supplementary to any angle on top. Then we get to the fun guys, these kites. Kites are a special one. You don't spend a lot of time talking about them when you're in younger grades because they don't have parallels. And so people don't seem to think they have a lot of special properties, but they do. Now remember that for a kite has no parallel sides, and so you don't get to use any of that. But the adjacent sides are going to be congruent in two pairs. So these adjacent ones on top are congruent. I've marked them with 2 marks. And these guys on the bottom are congruent. But they aren't congruent to each other, obviously. That's why these ones are marked with 2 and these ones are marked with 3. So 2 different sets of adjacent congruent sides. This gives you all sorts of fun properties. The first one is that diagonals are going to be perpendicular. And so if we think about every kite you've ever seen in any show, Mary Poppins, anything else, it always does seem like it makes a perfect T, and they actually do. So the diagonals are perpendicular. So if you ever see one of these and I tell you, yep, it's a kite, or if you see that you have 2 sets of adjacent congruents, then you can know that every single one of these angles here is going to be a right angle because that's what perpendicular means. The diagonals also have a fun property that there's a long one and a short one. Okay, since these 2 sets of sides are not congruent, one of the diagonals has to be longer than the other. The long one always bisects the short one. And so you can see that the short diagonal here is marked that each half is congruent. That's because each one of those 2 pieces is congruent. Okay, so the long diagonal bisects the short one. So not only is it perpendicular, it bisects it. Now the short guy does not bisect the long one. You can see that this part here on top is nowhere near as big as the one on bottom. But the short guy is going to be bisected. This long diagonal not only bisects its other diagonal, it also bisects the angle at one end and the angle at the other end. So the long diagonal bisects the opposite angles that are on either end. So this angle up here is bisected into 2 congruent pieces by this long diagonal. And then down here at the bottom, the long diagonal also cuts this angle into 2 little congruent pieces. Doesn't work for the short guy. He doesn't do that, but the long one does. So the long diagonal does all sorts of interesting things. Guess what else it does? Since it bisects these angles and this segment, then this big triangle on the left and this big triangle on the right are congruent triangles. And so you've got all sorts of congruent things. This is very symmetric. This left triangle will fold over and match right up to this one on the right. 2 congruent triangles there. So that long diagonal is a busy fella. What does the short diagonal do? The short diagonal connects congruent angles. So this yellow angle on the left, this yellow one, is congruent to this one on the right. That makes sense because of CPCTC. Since the big triangle on the right is congruent to the one on the left, this yellow angle has to be congruent to this yellow angle. So the short diagonal just points to 2 congruent angles on your kite. This angle on top and this angle on bottom are not congruent. They're bisected, though, into sets of congruents. But the big angle on the left and the big angle on the right at the ends of the short diagonal, those guys are congruent. And then lastly, this short diagonal becomes the base of an isosceles triangle. If you look here at this top piece, it's got this green segment, and this green segment are the congruent, and that makes this top section of your kite an isosceles triangle, which gives you all those little properties that isosceles triangles have. Keep that in mind as you do your homework. And then here on the bottom, the short diagonal turns this guy into an isosceles. So you've got this green piece here, and this green piece here makes an isosceles triangle on the bottom. So you've got an isosceles on the top and a different isosceles on the bottom, thanks to that short diagonal. So lots of properties going on here with your kite and your, I'm trying to go back to your trapezoid. There he is. So your isosceles trapezoid, and then your regular trapezoid, lots and lots of things. So you're going to be using all those properties now, as you see on your homework, to identify all sorts of fun little things, figure out the different sizes of angles and the lengths of sides based on all these properties. Thank you, team. We'll see you for the next lesson.